Okay, number 10, let's get this thing done. A dairy farmer plans to enclose a rectangular pasture adjacent to a river, right? So there's a rectangular pasture. These sides are the same length. Adjacent to a river, the pasture contains an area of, let's see, 1,800 square meters. The pasture must, okay. So that means the area must be 180,000 square meters to provide enough grass for the herd. Find the dimensions that require the least amount of fencing if no fencing is along the river. So, we want this to be the case. This is going to be width. That's going to be length, width. And so we know that the fencing is equal to 2 widths plus a length, right? So we'll call that our F. And this is what we want to minimize, the amount of fencing. So we know at some point we're going to have to take the derivative of this function. We don't want to do it now because as of now, well, right now, F is a function of W and L. So we don't like the fact that F is a function of W and L. That's kind of bad, right? We just want it to be a function of one thing. So now F is a function of both W and L. We don't like that. And so what do? We say since the area is equal to length times width, that means that 180,000 is equal to length times width. So that means that length is 180,000 over W. So we can go back here and substitute in, and we know that this is 180,000 over W. So why is that great? That means, okay. So that means...
But it really is perfect.
I know, it really is perfect. So if we have this, then what happens? Then F is equal to 2W plus 180,000 width to the negative 1, right? So if I take my derivative, I get 2 plus, or 2 minus 180,000 W to the negative second. So really what you're going to get is, now what you have is 2 minus 180,000 over W squared. But remember, caution, we like to get F prime into one term. So the way that we can get that thing into one term is by hitting it with hit this with a W squared over W squared, a nice well-chosen one. And so we get this. And what does that mean? So that's going to be the length, but I'm finding the width. Okay. So it's going to be 300. Okay. Yeah, it's going to work out perfectly.
Oh, wait, what?
So what we're going to do is, it's this, all of that over W squared. So we know we have two options. Now we're either going to have the derivative equals 0 or the derivative is undefined. Well, derivative undefined would mean width equals 0, which is garbage, or, because that would be the denominator equal to 0. In this case, if the numerator equals 0, that would be 2W squared minus 180,000 would equal to 0. So now we solve. And we get 9,000, right? Is that 9,000? Yes. Okay. And so now that we have that, now what you have to do is you have to think, what is the square root of 9,000. Why does that not make me super happy? Hold on one second. So let's go back up here. So just double checking something. So we have 2 widths plus a length. If area is equal to length times width, it's this, which is that. Put that in here, which is this. Derivative is 2 minus this. It's that 2w squared. If you divide it by 2, this would be 90,000. This is 90,000. Sorry, not. Wow. Again, trying to do too many things at the same time. So, of course, if you take the square root of that, you're going to get 300, which you want. So that's 300 meters. And I think from there, so L has to be 600 meters. I think you'll see. So width equals 300 and length equals 600 meters. Minimizes, I would say, will have minimum fencing. That's what you want. Okay. So what else do I want? Burp, burp. And then here I want this. Okay. So then we talk about a box. So we got a box with a square base. So in this time it's a square base. So here's the base. We're going to call this S and S, or do you want to call it X? I want to get at least close. And before we leave that last one, just to be sure, if you look at the first derivative for our function, we see that if you look at this L or this W, if you look at this W, so here's our function up here, the first derivative. If you put in 300, you can see, notice that F prime goes from negative to positive at X is equal to 300. And so that's why we have a nice minimum. Okay, that's one way you can absolutely verify it's a minimum. So now back to 11. If we look at 11 and we have a square base, maybe we call this X and we call this X. And so now we have an open box on top. So it's an open box on top. Yes, that's drawn just fantastically. And so we're going to call this Y right here. And so there's our area on the bottom. Area on the bottom. Let's see. So we know that we want our volume to be 108 cubic centimeters. Find the dimensions that minimizes the surface area. Well, we know that in this case, the surface area is equal to the bottom, which is x squared, right? And don't forget it's an open top, so there's not going to be a top. We would say that this side over here on the right is going to be an xy. This side over here on the left is going to be an xy. This side on the front is going to be xy, and same thing for the back. So I think we're going to have 4 xy's, right? So plus 4 xy. This is the bottom, and that's the sides. So as of now, here's the function that we want to minimize, but we don't want to minimize it right now because s is a function of x and y. Oh no, x is a function of s and y, so we have to make some sort of a change. Well, if the volume is length times width times height, length times width times height, it's just x squared y. That means that everywhere where you see, that means in our case that 108 is x squared y. So everywhere where you see y, you can replace it with 108 divided by x squared. So x squared plus 4x, 108 over x squared. means that our surface area is x squared plus 512 over x. So there's now the function that we want to minimize. I think before we take its derivative, we can change its form like so. And now we get that s prime is 2x minus 512x to the negative second. In other words, it's 2x minus 512 over x squared. Why is that doing something weird? Why is that doing something weird? You're going to make it negative. Why is it doing something weird? Hold on a second. So is that 512? I'm sorry, that's 432, not 512. That should be 432. So that should be 432. And so that's going to be 432. And that's going to be 432 over x squared. But now, remember, we like to get f prime to be one term anytime you can before you set it equal to 0. So here, we're going to hit this with an x squared over x squared, which gives us 2x cubed minus 432 all over x squared, right? So now we have two options. Either set it equal to 0 or say where it's undefined. This thing is undefined when the denominator is equal to 0. That would tell us that x is equal to 0, which is garbage in reality. But in context, that makes no sense. But then we have 432 is equal to this, which means x cubed is 216, but the cube root of 216 is just 6, right? But I want you to note that if you take f prime and it goes from, if you look to the left of 6, it's negative, and to the right of 6, it's positive. So since f prime goes from negative to positive, just 1 second, kid, that means that you have a minimum at x is equal to 6. And so dimensions that minimize, I'm almost done, kid, that minimize surface area. Is that a shower tub? Yes, that thing up there is. Oh, you want to look at? Okay, here, that's yours. That's your English book from school. They sent it home with you. So dimension that minimizes surface area would be 6 by 6 by, and to get the top, you notice that if x is equal to 6, y is equal to 108 divided by 6 squared, so it's going to be 3. So this is going to be the dimensions that minimize the surface area. Whew. So now I'm going to look at number 12. Let's do some antiderivatives. So if you have this and you need to, bless you, Eleanor, and you need to find the most general antiderivative, well, you're going to look at big F, you're going to pull out a constant, and you remember that x to the n, its antiderivative, x to the n plus 1. Yes, I did say pull out a consonant. No, I didn't. I said constant. So if that's the antiderivative, then we're going to have x to the 10 over 10. I pull out this constant, and I'm going to have x to the 7 over 7. Pull out this 12, I have x to the 4th over 4. And don't forget your plus c, right? So that's going to give you 4/5 x to the 10th. I know, I was fibbing, my bad. Okay, next time I will tell you the truth, kid. So there's 12. Let's look at 13. We have, I'm going to write as x to the 3/4 plus x to the 4/3. Now I'm ready to find the antiderivative. So this is going to be x to the 3/4 plus 1 over 3/4 plus 1 plus x to the 4/3 plus 1 over 4/3 plus 1. But you know that 3/4 plus 1 is the same as 3/4 plus 4 over 4, which is 7/4. So this is x to the 7/4 over 7/4. And over here, 4/3 plus 1 is equal to 4/3 plus 3/3. So you get 7/3. So this is x to the 7/3 over 7/3. So you're going to get 4/7 x to the 7/4 plus 3/7 x to the 7/3. And don't forget your plus c. If you do, it's infinitely wrong. Okay? So that's 13. So let's look at 14. So then we look at number 14. And it is 5e to the x minus 8 secant tangent plus 2 over x. Well, if that's f, well then the antiderivative, again, you're thinking what do you take the derivative of to get this? Well, the antiderivative of e to the x is just e to the x. Pull out this 8 and you think what do you take the derivative of to get secant tangent? And the answer is secant. And then I pull out the 2. You're going to think of 2 to the x as 2 times 1 over x. So the antiderivative of 1 over x is ln absolute x. And don't forget your plus c. You know that you can always check your answer to these type of questions by taking the derivative. Well, then 15. So then 15 says, look, if the derivative is the square root of x, 6 plus 5x, then find f. Well, we know when we find f, it's going to create a constant that we have to solve for, and we're going to use the fact that f of 1 is 6 to find that constant. Right? So before we do anything, we are going to change our form to x to the 1/2, 6 plus 5x, and then we're going to distribute through this x to the 1/2. Notice we haven't done any sort of antiderivative yet. All we've done is change the form. A lot like when we had derivatives and we changed the form before taking the derivative. So this is 6x to the 1/2 plus 5x to the 3/2, and now we're ready to take the antiderivative. Plot a 6, and remember x to the n, its antiderivative is x to the n plus 1 over n plus 1 for the antiderivative. And so when we do that, we get x to the 3/2 over 3/2. We pull out a 5, and we add 1 to 3/2. I know, right? We get x to the 5/2 over 5/2. And don't forget your plus c. Yeah, I think she's feeling better. The medicine's kicking in. And so when we come over here, I guess we're going to get, what? 2/3 6x to the 3/2 plus 2/5 times 5x to the 5/2 plus c. So that means we're going to get 4x to the 3/2 plus 2x to the 5/2 plus c. So there's our function, but to find out what it really is, remember, if you plug in at x equals 1, f of 1 is 6. So that means you get out 6 when you plug in 1. So plug in 1, and you end up getting that 6 is equal to 4 plus 2 plus a c. So c is equal to 0. Therefore, f of x is just equal to 4x to the 3/2 plus 2x to the 5/2. 16. So we look at 16, and we have the second derivative of x, and that's what makes this one interesting, is it's the second derivative of x is equal to 2 plus cosine x and you have two pieces of information, this and then f of pi over 2 is equal to 0. So when you get back to f, you can plug in those two things to solve for your two constants that are going to happen. So I take one antiderivative, I get 2x plus, well, what do you take the derivative of to get cosine? And your answer is sine. And then we take one more antiderivative back to f, and I pull out the 2. The antiderivative of x is x squared over 2. Those cancel out to give me x squared. Then what do I take the derivative of to get sine? Well, I could say cosine, but cosine is going to give me negative sine, so it's going to be negative cosine. So it's going to be negative cosine, and don't forget your plus c, right? But actually that c gets an x, and your new coefficient is actually plus d. So if we undo, if we had a constant, what do we take the derivative of to get a constant? It's a linear, that's why that's cx. Okay, all right. So if that's f, well, now we use the fact, we use these, what are called boundary conditions. So we use these boundary conditions on our interval and say, look, paste. If that's true, which I'm going to put here, if that's true, then what function are we talking about? Well, if you do f of 0, I think you see that you get 0 squared minus cosine of 0 plus c times 0 plus d. Well, the cosine at 0 is 1. So first, this is that, which is where this comes from. And then this should be negative 1 plus d. So we get that d equals 0. So then that means that f of x is x squared minus cosine x plus cx, because d is 0. But then we know that when you plug in pi over 2 and square it, or when you plug in pi over 2, excuse me, you end up getting 0 out. So what happens there? Well, when you square it, you get pi squared over 4. The cosine of pi over 2 is 0 plus pi over 2c. So you get that negative pi squared over 4 is equal to pi over 2c. But then to get rid of that pi over 2c, you multiply both sides by 2 over pi to get rid of that 2 over pi. So this cancels. You get c on the right, and on the left, you get a 2 on the bottom, pi on the top, and it's negative. So negative pi over 2 is what c is. Thus, f of x is equal to x squared minus cosine x minus pi over 2 x. That is your function. If we look at 17, if 17 is f prime of x and it's equal to x squared minus x to the 2/3 over x to the 1/2, and f of 1 is equal to negative 1/3, then I should be able to find out what f is. Well, before I do anything, I'm going to rewrite that as this over this minus this over this, right? But why is that weird? This should be an x, not a 2. But I know that 2 minus 1/2 is 4/2 minus 1/2, which is 3/2. So this is x to the 3/2. Over here, if I subtract these exponents, 2/3 minus 1/2, I would have to do this and this to get 4/6 minus 3/6 is 1/6. This is x to the 1/6. So that would be my derivative before I've even taken an antiderivative. Okay, so now I'm ready to take an antiderivative, and I know that I get x to the 3/2 plus 1 over 3/2 plus 1. I get minus x to the 1/6 plus 1 over 1/6 plus 1. So what does that end up giving you? I think you're pretty much convinced that that's x to the 5/2 over 5/2 minus x to the 7/6 over 7/6. So that's 2/5 x to the 5/2. Easy for me to say. And you get this, right? So what does that mean? Well, don't forget that we already said that f at 1 is negative 1/3. So you get negative 1/3 when you plug in 1. Back here, you would have gotten, as soon as you took this antiderivative, don't forget we got a plus c, and that's what we have to solve for. And that's why now, while we plug in to solve for that c, that's really what we're doing. And so what you get is you get that c is equal to negative 1/3 minus 2/5 plus 6/7, which, if you love fractions, that turns out to be 13 over 105, which is ridiculous. So your function is 2/5 x to the 5/2, minus 6/7 x to the 7/6 plus 13. You know fractions? It's because you're super smart, kid. 2 problems left. I'll do those in the next video. Peace out, Girl Scout.